All right, the test is going to be Thursday. Yay. How was that evil?
That looks disgusting. Here's that last one.
You're making them look square.
It looks happy to me.
Is that better? It's above it now? Okay.
Put two eyes above the U. Okay?
I'm recording. Why am I recording? Hey, the test is Thursday. We're going to be ready. Today we'll wrap everything up. So fire away, friends. Solubility products, also known as KSP. What does products mean in math? Multiplication. All right. Thank you, Jeffrey. KSP is the easiest one of all of them. There's a good reason. So what's this thing right here? What does that say? Solid. What do we do with those in the equilibrium expressions? We ignore them. So if we say our KSP, that means the solubility product, and we just do this KSP thing when we're dissolving solids, we would say it is equal to the concentration of Ba plus 2, I guess, times the concentration of SO4 minus 2. Is there any dividing? No, because there is only a solid reactant, so it disappears. So the concentration of these depends on how much the thing dissolved or its solubility. And since we're taking these solubilities and multiplying them, we just call them the solubility product. All right? Rarely does something actually sort of make sense in chemistry language, but that one usually does. You okay with that? All right. Here's something cool, too. The concentration of this will be equal to the concentration of this, won't it? Because for every one Ba that breaks off, how many SO4s break off? 1. So these two numbers in this particular example will be equal to.
So it'd be like a square.
Yeah, sure. So if I just said this was equal to X for Ba, and I said SO4, well, it'd also be X for Ba. It'd be X times X, or this KSP could be simplified into something very simple, and we would say it's equal to X squared. Now, knowing that, if I knew the concentration of one of these, let's just say the concentration of Ba was 1 times 10 to the negative 4th. All right? Well, then all I had to do was square this, and it would tell me the KSP. Okay? Not bad, right? Compared to what we've been doing. That's not too bad. All right? If I knew KSP, I could take the square root of that, and it would tell me the concentration. Okay? So now this is easy, and it only works if you have a 1-to-1 ratio, but we'll learn how to do the other ratios too, because they're not that bad. Okay? I certainly went out of order here. The equilibrium constant expression for this would be that, where the equilibrium constant KSP is called the solubility product. Once again, because we multiply the concentrations which are dependent on their solubility. The solubility products. All right, now, here's where we are already going to talk about things that make it a tiny bit harder, but it really isn't that much worse. The expression for a solubility product does involve stoichiometry. The equilibrium constant expression for this one would now have the Cl2, because remember the coefficient becomes the exponent. This is an uppercase, or not uppercase, you know what I mean. Superscript 2. Okay? So when solving for the concentration of an ion, make sure to account for the subscripts in the formula. Okay, now, I don't know why, but for 2 or 3 kids a year, this right here does not click. But I'll do my best to make sure 100% get it this year. Okay, so follow my logic here. If BaCl solid dissociates, it forms Ba and 2 CLs. We're okay with that. So my KSP would be equal to BA, and just the pluses and minuses are here. I just didn't put them, but whatever. All right, and CL squared. We okay with that so far? Okay, now what I need you to make sure and understand is this part. If this dissociates, it's going to produce 1 BA and 2 CLs. Okay? So if I say BA is X, then 2X would be the amount of chlorine, correct? Right? Are we okay with that? Hold on. I need to buy him a subwoofer or something. I was sure just all up. I actually was at a funeral and they played that song, so now it like hits up my feels. It was weird, but it was pretty powerful. Let's put it that way. Okay, now go with me here. If BA is X and CL is twice of X or 2X, we then substitute these concentrations or variables into the actual KSP rule or law or equation, whatever you want to call it. So BA would be X, but CL would be twice as much as X. Is everyone okay with that? CL would also be squared, though, because the actual KSP law, since there was a 2 here, it also is squared. When I do this math now, it can be simplified, because if you square 2x, you get 4x squared times x. You end up with 4x cubed. So KSP is equal to 4x cubed when it's a 1-to-2 ratio in your chemical formula. Okay? Most of the kids that make a mistake, if they do it all, they forget this 2. It's there because for every 1 that broke off of BA, 2 CLs broke off. The good news is that if this did not make sense to you, which about 4 of you did not raise your hands, if you can just memorize this I just put in the red box, then you don't need to understand why. If you see something that has a subscript of 2 to a 1, you just can memorize that to solve for KSP or to X, it's this equation. KSP equals 4X cubed. And now what is X? X is the concentration of the single ion. So if it's BaCl2, the single ion is the Ba versus the double. You okay with that? Okay. If we can solve for Ba, then we can solve for Cl, because it's just twice that number. Okay. So, math. You must be able to use KSP to solve for the concentration of any of the ions, and you must be able to use the concentration of any of the ions to be able to solve for KSP. So here's our first 2 problems. All right? So what is the concentration of Cl minus in a solution of AgCl if the KSP for AgCl is 2.35 times 10 to the negative 8? So the first thing you would do is write your rate law. KSP equals, there's no subscripts here, right? So it's just Ag to the first and Cl to the first. Then you plug in what you know. 2.35 times 10 to the negative 8 equals, what's nice about these 2 values? They're the same. So if I call them x, I can call this x squared, right? Because it's the number twice. All right? And so then I can take the square root of both sides, and I am ready to roll. No, if there's a subscript, well, yeah, you would divide by 4, sorry, and then cube it. All right, we ended up with, all right, well, that's what he said. Okay, that's the same thing. No, you're fine. Okay, well, that wasn't that bad, right? As long as you can, like, if you memorize this, if it's 1-to-1, KSP equals x squared. If it's 2-to-1, KSP equals 4x cubed. If it's 3-to-1, it's 27x to the 4th. We'll talk about that, but yeah, whatever. Okay, here we go. What would the KSP for HgCl2 be if the concentration of Hg at equilibrium, I should have ended this with a 3, and then it would have been like a sonnet. 4.35 times 10 to the negative 11. All right, now this one does have a 2 here, so you would write your KSP. What's that? All right, you have your Hg. Once again, I'm being lazy on the signs, but they would technically be there. And then it'd be Cl squared, right? And then I'm going to plug in what I know. Now, hold on. We will use the 2, but not in the law yet. Okay? So, really good question. Did everyone hear his question? The 2 comes in later, but it's not part of the expression. Okay? Because the 2 doesn't come in until we say, all right, I know Hg is this number, so Cl will be twice that number. All right. Because the 2 is it's coming from if you are given just this concentration, which we are, right? This concentration has to be 2 times that value, right? And so now that this is 2 times that value, we also still have to square it. All right, so we're going to put in what we know. So we want to solve for KSP, so we don't know that yet. KSP is equal to Hg's concentration, which is 4.35 times 10 to the negative 11, times, and this is the way longer way to do it, but that's okay. So this would now be 8.70, right? If I double it, 10 to the negative 11. Okay, if that doesn't make sense, all I did to get this number was I multiplied this one by 2. Okay, so that's where the 2x comes from. But I also must do what to Cl's concentration? I have to square it. So we can plug all that in. And this is the longer way to do it, so we'll talk about that just here in a second, the shorter way to do it. This one might be requiring a lot of parentheses. That's a really small number, huh? So what did we get? Okay, wow. And that's what happens when you make up numbers. I got a question. Is this very soluble? No, heck no. Now, I made these up, but the smaller this number is, the less soluble it is. This would be like dropping a rock in water and just waiting for 20 million years to see if it's solved. It won't. Like, this is a really small number. Okay, now, this is the longer way to do it that you can do. Or, if you remembered, since it was a 2-to-1, KSP was 4x cubed. Okay? So, KSP will equal 4 times this number, 4.35 times 10 to the negative 11 cubed. You should get the same number either way. Okay? So, this is the most correct way to write it out and do it. And it worked. But if simplifying it, we know that we're going to have it doubled, then we square, so that's where the 4 comes from, and there's my x. We know it's cubed because x was here once and x was here, but it was squared. Okay, the 4 once again came because this value was twice as much as that value. Okay. You have to be able to go both directions. Now the good news is, once again, it usually is only either KSP equals x squared, or where this is a 1-to-1 ratio, right? Or it's KSP equals 4x cubed, where that's a 2-to-1. Well, usually it's 1-to-2, but it doesn't matter either way. Ratio. Okay? All right? Here's the same thing from last year, probably. All right? Since it's 2, we put the square. If we only know PB, CL is twice the amount of PB, which is still squared. That's where the 4 came from, and the x cubed. All right. We don't need to spend a ton on this because this hardly ever happens, but if it's a 3-to-1 ratio, all right, you get 3-to-1 ion. That means one of these is cubed. Okay? That also means if you only knew the 1, which is what they will give you on the test, that's x. If this broke into a 3-to-1 ratio, this would be 3 times whatever that value was, but it would still be cubed. Okay? When you multiply all this together, 3 cubed is 27. X cubed is x cubed. Multiply it by another one, you get x fourth. So if, and this is extremely rare, if it's a 3-to-1 or 1-to-3 ratio, KSP is equal to 27x to the 4th. Okay? Now, I don't test you on that one, and I don't think I've ever seen a cube on the actual AP test. So don't fret a ton, but if you want to commit something to memory, there is something right there. That was a terrible. I got to undo that. Well, the undo's covered. Oh well. Okay, just a couple more examples.